So question 12 says factor the given polynomial completely. If the polynomial cannot be factored, say it's prime. So one of the things we pick up on is, when I have a polynomial, if I want to factor it, well, basically what we're looking for is a binomial times a binomial. So we're going to have a set of parentheses times another set of parentheses. So as an example, if I had x plus 3 times, say, x plus 4, one way to kind of look at this is we have, if I want to look at it from the box point of view, it's an easier organizer. So this x plus 3 would be on the outside. This x plus 4 would be on the outside. If I partition it, notice that x times x is going to give me this x squared. It's on the inside. X times 4 is going to be 4x. And then this 3's got to go through there. 3 times x is 3x. And 3 times 4 is going to be 12. So if we look at this, we're going to see then this x plus 3 times this x plus 4 is going to equal this x squared. Notice how the 4x and 3x are alike. So those go together. They're added together. That's going to give me 7x. And then there's this 12 here. So what we pick up on is now we're giving you this x squared plus the 7x plus this 12. And we're trying to write it as a factored form. So things to note in the box is the quadratic term or the x squared term. Notice how it's in this top left. So notice how this x squared is here. This 12 is in the bottom right. Now notice the 7x is actually broken apart. It's going to be a 4x and a 3x. But notice that this 4 and 3 are actually factors of this 12. So if we note this in like a table, the factors of 12 would be 1 times 12, 2 times 6, and 3 times 4. But notice this 3 times 4 is the only one that gives you the 7, the coefficient of what we call the linear term. So 7 is the coefficient of linear term. And that's what we're looking for. So we're looking for the factors of this 12 that add up to give you the middle term, which is 7. So if I was going to do this problem here, notice that the x squared is going to be coming from the first two terms. So this is going to be your x and your x. Now the catch is what I need to go in these last two positions are the factors of 13. Well, there's only one pair of factors for 13, 1 times 13. But the question is, does 1 plus 13, does that actually give me 14? Well, yeah, it does. 1 plus 13 is 14. So what this tells me then is this is factorable. And what I do is I put the factors of the 13 in the last positions. So the plus 1 and the plus 13 go here, and that would be the factorization of this. So again, what makes this easy is the front term is just x squared. The coefficient of this quadratic term is just a 1. So all I really got to do is focus on are the factors of the last term, the 13. So again, if I want to look at this in a box format, if you need an organizer for this, if you're trying to factor x squared plus 14x plus 13, what happens is the quadratic term goes here, and the constant goes here. And what we're looking for are the factors of 13 that add up to the 14x. So notice that this 1 and 13 would work. So what I can do is put a 1x here and a 13x here. It doesn't really matter where those go. Now the catch is, if you're using the box method, is if you look at this row across here, what does an x squared and a 1x have in common? What's their GCF? Well, their GCF is going to be simply an x. So what I can do is pull an x out. If I pull an x out, and then what we got to pick up on is what goes here that multiplies to x that gives you x squared. Well, that would have to be an x. And then we have to ask what goes here that multiplies to an x that gives me 1x. That has to be a 1. And then we're down here. What can we multiply by x to get a 13x? Well, that's got to be a 13. And well, 13 times 1, does it give me this 13? Yeah. So notice how we do have this x squared, this 14x, and this 13 on the inside. But the factorization actually occurs on the outside. So these are my two terms of my first expression. And these are my two terms of my second expression, my second binomial. So x and 1 or x plus 1, and x and 13 becomes that. So those are the two ways to kind of factor a polynomial. Is I can use the box method, or I can just simply use FOIL, thinking what makes this easy in FOIL is since the coefficient, or since the first term is just x squared, we know x and x have to go in the first two positions. The catch is, what are the factors of a 13 that have to give me a 14? If you can answer that question, that's going to be the two factors we put in the last two positions. So the x plus 1 becomes the first binomial, and the x plus 13 becomes the second binomial.